Hello there, this is a Year 12 Maths exercise 15C lesson on integration again, and this time we're trying to find this constant of integration. And there are times when we have to write plus c, but there are other times when we do an integration we write plus c, but then we go all out to try to find what that c actually is, and there are ways of doing that. So a little starter for us, just looking at it quickly there are basically three questions which are asking us to integrate. The first one is this backward differentiation one. So we've been told what dy by dx is, and we're then asked to undo the differentiation. That we do by integration. So this is equal to, I add a power. Do you remember this rule? Add a power and divide by the new power. So it's 3x to the 6 over 6 plus 2x squared over 2 plus a constant. But this I can tidy up. 3 divided by 6 is a half. X to the 6. 2 divided by 2 is 1, so just x squared plus a constant. There you are. Done. What's in the next one? Now this one is just, it's a straight out find the integral of question. So again the rule is the same. 6x cubed add the power, divide by the power, minus 4x squared add the power, divide by the power, plus 8, and if it's ever got 8, it becomes 8x. Plus a constant. So now I tidy up. 6 divided by 3 is 2x cubed. 4 divided by 2 is 2 minus 2x squared, therefore plus 8x plus c. Like that. And this one's another, well, this one's an equivalent version of this. dy by dx equals, here, this is another way of writing it, f dash equals. It's been differentiated, we've got this. Now find f of x, undo the differentiation. So this is equal to, add the power, 8x to the 4 over 4. And it's very common to be given a new power which then will divide into what you've got. They deliberately set these up. Sometimes they don't. Look at this one didn't. Minus 9x plus c. So if I tidy that up, I get 2x to the 4 plus, well, 5 over 2 or 2.5 even, doesn't matter which, minus 9x plus c. Just looking very quickly, make sure I've got them all right. I do seem to have done. Look, here's the rule then for integration. Our rule said add the power, divide by the new power, don't forget to add the c. And I've even, at the end of the last PowerPoint, showed you that this is basically easily written like this. The integral of ax to the n is ax to the n plus 1, divided by that n plus 1. Add the power, divide by the power. Now, if we want to find the c, then we're going to need to be told something new. We're going to have to be given some additional information, and that additional information is almost always something about a coordinate on the point of the on the curve. So here I know, for instance, when x equals 1, y is equal to 2. Now, it doesn't help me initially. dy by dx is all I know. I haven't got any y's in there at all. But in the bit, once I have integrated, it will help. So let's integrate this. This tells me that y equals, add a power, x cubed over 3 minus, add a power, x squared over 2 plus 2x plus a c. This is when it helps me. I've got y's, I've got x's. I'll let me find c. So I'm going to sub x equals 1 in and y equals 2. That gives me that 2 equals 1 has got to be cubed, which is 1 divided by 3 is 3. Quite nice that it's 1 cubed because it doesn't change. Minus, now 1 has got to be squared again, which again is still 1 divided by 2. Plus, and it's 2 lots of 1, which is 2. And you see effectively you've got this equation now that lets me solve. So on the right hand side I'm doing a third minus a half. I might as well do this properly. Add 2. That gives me 11/6. So it says 2 equals 11/6 plus c, and I can move that 11/6 over, and I reckon c is a sixth when I do that. So, but notice what I've now done. Y now isn't equal to x cubed over 3 minus x squared over 2 plus 2x plus c. No, because I know what c is. And notice then my final line should always be rewriting the equation without the c. And now I've written plus a sixth now, rather than plus c. See, it's just subbed in. And that's the answer I want. Okay. So a couple of example questions for us. I'll do them both, but you might want to pause the video and see if you can do them both. Find the equation on the curve of gradient function f dash. Again, this is a dy by dx thing. These questions almost invariably are, I've done the gradient, found dy by dx. Now work backwards to find the c. So if I was doing this, I'd write f of x equals add a power, so it's minus a half x squared over 2. Now that's, you can see the two 2's on the bottom, so that's like minus x squared over 4 plus a constant. Can't forget that constant. Now this is another way of writing it. Look at this. This basically means x equals 2 when the function, this is almost like a y equals, or f of x equals minus 2. So I can sub that into this, so I can now say f of x is minus 2 equals, now this was my function here, wasn't it? It was minus x squared, x is 2, so minus 2 squared divided by that 4 plus a constant. Now 2 squared is 4, minus it is minus 4. So I reckon minus 2 equals minus, so minus 4 divided by 4 is minus 1 plus c. And if I move that over there, I reckon I get c equal to, what, minus 1. So my equation, I nearly wrote a y equals there, but it was f of x, so I reckon I can make that look like an f on this. F of x equals minus x squared over 4 minus 1. I know it says plus c, but it turns out to be negative, so it just becomes negative. Not sure if that comes up. Minus x squared over 4 minus 1. Yes, it did. And the next question, dy by dx equals this. Well, first of all, I'm going to multiply this out. So I'm going to write dy by dx equals, multiply that out, gives me x squared plus 3x plus 2. I'm sure you're good at that by now. But now I have to integrate to get my y. So add a power. Gives me x cubed over 3. Plus 3x squared. Notice I've added a power, divided by the new power. Plus 2x plus a constant. So my job is clearly now to use this point here. It tells me this curve passes through the point 2, 1. So therefore I can say from that x has got to equal 2 when y equals 1. Substitute those in. 1 equals, notice it kind of goes the wrong way around, 2, 1, but the first thing I wrote was the y, which is the 1. Now, what was this? That was x cubed over 3, so it's 2 cubed over 3 plus 3 lots of 2 squared over 2 plus 2 lots of 2 plus c. I reckon if I work that out, 1 equals something plus a c. What does that something give me? Just do it on the calculator. I've got, the first one is 8/3 plus, well, 3 times 4 is 12, divided by 2 is 6, so plus 6 plus 4. I've got 38 over 3. And obviously what I'm going to do is I'm going to move that onto the other side and subtract, and that will give me 1 minus that answer is minus 35 over 3. All done on the calculator. You don't need to kill yourself for working too hard on this. And therefore my equation is y equals x cubed over 3 plus 3x squared over 2 plus 2x. And again it's a minus 35 over 3. Let's see if my answer agreed to that. Yes, it did. Minus 35 over 3. Alright, this is, I think this is a good example from the textbook actually. A curve as a second derivative. Now we've not seen anything like this. So we've got to do a bit more work. This basically means it's been differentiated twice. So when I first integrate it, well, we've already seen that. If I start off with dy by dx and I integrate it, I get y. So if I integrate it. But what happens if I don't start off? Well, imagine I got d2y by dx squared. If I integrate that, I will get to dy by dx. And if I integrate it again, obviously I'll get back to y. So I've got two stages. I can write now dy by dx equals, I'm going to integrate this. This is 3x minus 6x squared over 2. Don't forget your constant. What's that? That gives me dy by the x equals 3x minus 3x squared plus a constant. Now, it says its gradient at this point is minus 3. So that's basically a posh way of saying dy by dx is going to be equal to minus 3 when at this point. Now, this point is 1, 2. Now, critically, that is x equals 1 and y equals 2. So when x equals 1. So just from here then I can say, okay, dy by dx is minus 3, and that equals 3 times the 1 minus 3 times 1 squared plus a c. And you quickly think, well, times my 1's not going to change much. 3 take away 3 in fact disappears, and therefore c equals minus 3. And therefore my dy by dx equation is 3x minus 3x squared minus 3. Now I've got to do a bit more work though, because that's just dy by dx, and I want the equation of the curve, and that's a posh way of saying what's y equal to. That's what I'm after. So I'm now going to have to integrate again as part of my discussion up here. It gives me 3x squared over 2 minus 3x cubed over 3 minus 3x plus a new constant. Now some people write C1 and C2. It doesn't really matter. Some people write K for the second constant. I also know that it passes through this point, x equals 1, y equals 2. So let's substitute those in. Y equals 2. And by the way, this can be simplified a bit, can't it? 3 over 3 is 1, so I can ignore that. So it's 3 times by the 1 squared over the 2 minus 1 cubed minus 3 times 1 plus c. So the different way, 2 equals 3 over 2 minus 1, minus 3 plus a constant. 3 over 2 is 1.5. Minus 4, I think, is minus 2.5, which I move it over is 4.5. I reckon C is 9 over 2. But I'll soon find out. It was 9 over 2. And notice again that final line where you write out the full equation. The equation that you just got, but rather than the plus C, you've changed the C to the thing you just found out. A little thing just to think about at the end. Integration is defined as the reverse of differentiation, I've said. That's the way I've defined it to be. We know that the differentiation, though, represents the steepness or gradient of a curve. So if I've got a curve, it might be, say, at that point there, I want to know how steep the graph is. And to do that, I effectively find the tangent at this point. And to do that, I use differentiation. Differentiation represents the gradient. And so the big question is, what does the integration represent then? We've got integration, we're doing it. It's the opposite, presumably, of this finding the gradient stuff. I wonder what it really represents. I wonder what it means. And this is something we're going to come on to in the next lesson or so. Okay, so this is an important idea, that we understand not only that differentiation gives us the gradient of a curve, but also I want to know what integration represents as well. Before that, we're going to do exercise 15C on page 299. Thank you very much.